In this video, we're going to talk about a time series graph. A time series graph is, or represents, data that can occur over a specific period of time. So as you're learning these different ways to illustrate your data, keep in mind some words that make sense. Time series over a specific amount of time. So we can get some data. Notice this has years and then it has costs. But notice what, right over here, notice what it ends up looking like. When you go across the time, there are dots, and they are going to correspond to, like at 2010. At 2010, we're at 1.4, or $1.40, or in this case, millions. And so here at 2010, we're right here at 1.4. Notice what a time series has and what it does not have. Notice it does have the time on the horizontal. That's almost always a given. Time's going to be on the horizontal. When you're looking here at the time, and then whatever else is being used for this particular graph, notice it is dots. Notice that it is connected. It could go up, it could go down, depending on what you are looking at and trying to illustrate. But notice the first dot does not go back and connect to the x-axis, neither does the last dot, like the frequency polygon. So do make a very good distinction, know which one is which. And up here, if you want to go ahead and jot down some ways to graph a time series graph, it says draw and label the x and y. Remember, we're going to put time on the x. Label the x for years, the y for cost, plot them, and it says do not try to make this smooth. You're going to connect dot to dot to dot to dot to dot. And it could be, if you're looking at like the stocks, they could go up and then down, up and down and up and down, up, 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 whatever they're going to look like. I do want to add in a few more comments about the time series graph. When you analyze it, look for a trend or pattern that occurs over the time period. And that's going to be important in whatever data you present, that you look for trends and not just a snapshot of one moment in time. For example, if the line is ascending, indicating an increase over time, or if it's descending, indicating a decrease over time. Another thing to look for is slope or steepness. A line that is steep over a specific period of time indicates a rapid increase, or it could be a rapid decrease. Two or more data sets can be compared on the same graph, and again, the word we used a while ago, it's going to be a compound time series graph. And then as you're looking here, just asking yourself, what do you observe? And it's talking about the elderly and the labor force, and you can make some comparisons. I always like beginning, ending, and then tell something about in the middle. Like you could even start right here, that in 1960, about what the men were percent in the labor force, and about what percentage the women were. And then you can come over here to 2010 and make a comment about that. You can make a comment about a sharp decrease. You can make comments about steady, or a steady increase, or holding about the same. Not opinion, just reporting out observation. The next thing that we're going to look at in this video are pie graphs. Pie graphs are used extensively, and the purpose is to show relationship of the parts to the whole. So you're going to have one pie, and you're going to have to take that pie and divide it up by percentages. Well, let me just read. It is a circle that is divided into sections or wedges according to the percentage of frequencies in each category of the distribution. So we have talked about a similar formula earlier, frequency divided by n, the number of items that are in our whatever we're talking about. But we multiplied it by 100 to get it to percentage. So we're not going to multiply it by 100. This first part gets us to a percentage in decimal form, but we want to know what percentage of a 360, a full circle, our data are going to represent. So I'm going to keep going on over here to the next page, and I'm going to actually do a couple of these calculations. They're asking us to do, based on police calls, the number or frequency of those calls on a different shift. So we have lots of data, and we have a total. Remember, it says that a pie graph is showing how all the parts relate to the whole. So in all, we have 7,830 calls. So now we need to break each one of these down into its percentage, but more specifically, what percent of the 360. And so looking here is our formula. So for each one of these, we're going to take like this one, the 2594, put it over the whole, 7830, the frequency divided by the whole, and then multiply by 360. They've already worked these out, but it would be really, really good. Oh, and it showed us, oh, it says find the percentages. Well, now wait. Ah, I see. Okay. I didn't reread this before I started videoing this. So, you can do this a couple of ways. The formula they're showing is for us to talk 360. So when we do that first one that I was just showing you, where we take the 2594 and divide it by the 7830 right here, and multiply it by 360, it tells us our day shift is going to represent 119 degrees. Our evening shift, and when we do its calculation, etc. Some of you may or may not like the degrees. You may be very familiar with a 90 degree. And if it's a 90, just a little bit more than that would be 100, and a little bit more than that would be like 119, 129, or 112. So about a third, a third, a third. So if you're okay with that, you can go ahead and get your graph going. You can do one that's about a third. You can do another that's about a third, and another that's about a third. If you're not liking these degrees, you definitely can go back to the original one that we did. I'm again taking the part and dividing it by the whole, part divided by whole, and then I'm going to turn it into the percentage. See how these are about a third, and a third? And when you go to graph a third and a third and a third, it's the piece symbol. But notice here, we do need to make sure that evening is a tad bit the biggest one, and that the night is the smallest one. And so if you look at the finished graph down here, the finished pie chart, you see that evening looks a little bit wider, night is a tad smaller, and day looks like, you know, part of the piece symbol, that it's actually a third. To analyze the nature of the data shown in the pie graph, look at the size of the sections. So think about eating pie. Do you want a large piece or a small piece? For example, are any of the sections relatively large compared to the others? And the one that we just looked at, there are 3 shifts, and they all look about equal. They're all about a third, a third, a third. Although slightly more calls were in the evening shift. Nice word, slightly more. Computer programs, I know Excel does one very quickly, can construct pie graphs easily. So the math shown here would only be used if those programs are not available. The last thing I want to show you on this video, and even just to go back and look at where we have been, the first thing that we looked at was time series. Again, try to picture it in your mind, and that was a compound. What it looks like, what it looked like similarly to what we've done before. The other one that we've looked at are pie graphs. And now in this video, I'd like to finish up looking at what's called dot plots. And they're literally what they sound like. It's going to be a plot of a bunch of dots. And a dot plot uses dots to represent the data values, and they're plotted above one another. I like dot plots. If we were face to face, we would all stop and take our pulse, and then we would make a quick dot plot of everybody's individual pulse. And it's really cool how it turns out to be about a normal curve. It is a statistical graph in which each data value is plotted, and that's the part where I think students get confused, is finding out what each dot represents. Sometimes it'll represent 1,000,000 homes, and sometimes it represents a person and their individual pulse rate. Dot plots are used to show how they're distributed, and like if you start to see extremely high or extremely low data values. And so it tells us how we can do one of these, and these would be a great question for the test. I just wouldn't give you this many pieces of data. But when you go to graph the data, you put along a horizontal. You don't have a vertical, you just have a horizontal. I've got my note to do pulse if we were face to face. And on this horizontal, you then start plotting whatever this is talking about. So these are named storms. And so named storms, it says, you know, draw the horizontal line and then plot them. And so like right here, as you see that this whatever down here looks like a 4, there is a 4. But then if you look right in here, there seem to be a lot of like 9s. Oh wow, look here, 11 and 12. 12 looks like the big one with a lot of dots. And so if you started looking, there are 1, 2, 3, 4, 5 12s. And so for every 12, you put a dot, a dot, a dot, a dot, a dot. And the cool thing is it does start to look normal, like a normal distribution. Might even show you some outliers. Might even show you if it's bimodal. It can show you a whole lot of different things. So we talked about the 3 different charts, graphs, ways to display information, and we ended this video talking about dot plots.